In this video, we're going to be talking about evacuation, or putting a system into a vacuum after performing repair work and before you recharge it. A refrigeration system, and again, refrigeration system could be refrigeration or air conditioning. It's still a refrigeration system. Should only contain refrigerant in a liquid or vapor state and a compatible lubricant. However, when you have a leak or have opened the tubing to do repair work, moisture and other substances can enter the system. This can happen after refrigerant has been recovered and the system is open to atmosphere. In order to remove this unwanted moisture and the additional air and oxygen and other contaminants, the technician is going to evacuate a system. Evacuation is the removal of all vapors, gases, and fluids from a system. Evacuation occurs after the refrigerant has been recovered from the system and before the system is recharged. Anything that is not refrigerant or refrigerant lubricant is a foreign substance that can be removed by connecting the refrigeration system to a vacuum pump and drawing a vacuum on the system. The two methods of evacuation are deep vacuum or triple evacuation. The primary method we use is deep vacuum. So the primary difference between deep vacuum and triple evacuation method is the level of pressure achieved in the system and the number of times a vacuum is pulled on the system. By reducing the pressure in the system, a vacuum pump lowers the boiling point of any substance remaining in the system. The vacuum is measured in microns. Microns is the unit of pressure measurement in millionths of meters of mercury. Okay, so when we take a look at the boiling point of water, the higher the microns, basically the less of a vacuum. So when we first start, remember, water boils at 212 degrees Fahrenheit. So when we begin to put the system in a vacuum, as we lower the vacuum, we lower the boiling point of water. And again, this chart is the highest number is at the bottom. Okay, so inches of mercury. Microns go down as we put the system into a vacuum. So when we have a 70-degree room, we can boil water at room temperature by putting water into a vacuum. When an adequate vacuum is drawn, any moisture in the system will boil and will be drawn out by the vacuum pump. For this reason, evacuation for the purpose of moisture removal is also called dehydration, removing water. Non-condensables in a system are substances which remain in a gaseous form in a refrigeration system, such as nitrogen and oxygen. Effects of air or non-condensables in a system: you'll have increases in discharge pressure and it will stay stuck at the top of the condenser. So you will not have proper refrigerant flow and condensing through that condenser. If moisture were to remain in a refrigeration system, it would create acids such as hydrochloric acid and hydrofluoric acid. These acids are extremely dangerous to the compressor windings and will eventually wear the insulation off the windings, causing shorts to ground. In some refrigeration systems, the compressor depends on vapor flow to cool its motors and other parts. Do not use a refrigeration compressor as a vacuum pump to evacuate a system, as it can overheat and damage it. A vacuum pump is a specific device that's used just for that. Also, second word of caution: when you're putting the system into a vacuum, use lockout tagout on the disconnect of the system. You do not want any chance of someone turning it on while it's in a vacuum. You'll damage the compressor windings. If a system is unable to maintain a vacuum, the system has a leak. Even after the vacuum pump has been turned off and the valve to the pump has been closed to isolate the system pressure will rise steadily. Always repair all leaks you find. Drain before and after an evacuation. Another possible cause of insufficient or incomplete vacuum is moisture in the system. If there's moisture in the system, it will cause the system pressure to rise and level off after the valve to the vacuum pump is closed. The gauge reading will level off at a pressure corresponding to the water vapor pressure at that temperature. Okay, so when you take a look at pressure over time, if there's a leak, there's going to be a constant pressure rise. It's not going to level off, and it's going to constantly rise until it reaches atmospheric pressure. If it has moisture, the pressure is going to rise and level off. It's not going to continue to rise and till atmospheric pressure. So for the second one, you're going to turn the vacuum pump back on and continue your evacuation. For the first one, you're going to find the leak and repair it. Tips for performing evacuations. There's a few key practices that helps this go smoothly and easily. One of the most effective practices when performing recovery, such as are the same as performing recovery. Use short, large diameter hose, remove the Schrader valves using a Schrader core remover, and add heat to the compressor and other places moisture might freeze. Vacuum pump service lines should be as large in diameter as possible and as short as possible to negate any pressure drop. Pressure drop with evacuation is very important. It takes 8 times longer with a 1/4 inch line than with a 1/2 inch line. It can take twice as long using a 6-foot line compared to a 3-foot line. As short of hoses as possible. So large diameter hoses, short. In the process of lowering system pressures for evacuation, temperatures also drop. A rapid temperature pressure drop could freeze some of the moisture in a refrigeration system. To completely dehydrate a system on a cold area, or if you drop it too fast, a technician has to warm the system. By warming the system, any moisture in the system will be forced to vaporize so it can be drawn out by the vacuum pump. When heating a refrigeration system during evacuation, never use a torch. A torch can create localized high temperatures enough to decompose lubricant, insulation, and refrigerant. Heat should be applied by raising the ambient temperature or by using a heat gun or lamp. Always break the vacuum on a vacuum pump before storing it. Breaking the vacuum means equalizing the vacuum pump and atmospheric pressure. A vacuum pump should not be stored when it's in a vacuum or pressurized. If a vacuum pump's vacuum is not broken, the cylinder will fill with oil and the pump will become oil locked. Deep vacuum is an evacuation method in which the technician uses a vacuum pump to pull 250 microns or deeper until no moisture or other vapors remain in the system. A vacuum gauge is used to measure the pressure conditions produced by the vacuum pump. A vacuum gauge is installed between the vacuum pump and the refrigeration system by T-fittings. This is an example of a vacuum gauge. Again, the lower the micron number, the greater our vacuum is. Make sure these fittings are tight and make sure there's no leaks. Okay, make sure your hose fittings, the gaskets are good. When a vacuum pump is shut off, the gauge reading will rise from its 250 micron reading for approximately 1 minute. If the reading levels off and holds steady at about 500 microns, the system is leak-free, moisture-free, and ready to be charged. If the gauge continues to rise after 1 minute, there's moisture or leak in the system. When pulling a vacuum, standard synthetic charging or service hoses may collapse due to the deep vacuum. Synthetic hoses are somewhat permeable, meaning they allow gases to pass through them. Use specially designed refrigerant hoses, copper tubing, or special metal hoses for pump connections. So your metal hose and a heavy duty hose, that's what you want to use for evacuations. It can take a long time for a system to draw a deep vacuum. If the vacuum pump is going to be running for an extended period of time, unintended, throw a solenoid valve in parallel with the vacuum pump. If the power is lost during evacuation, the solenoid will close, preventing the vacuum in the system from drawing the oil out of the vacuum pump. You can pull the oil out of the vacuum pump if it's shut off without closing the isolation valves. Triple evacuation is a evacuation method in which the technician uses a vacuum pump to pull a vacuum of 1,500 microns 3 times. After the first and second vacuum, the technician charges the system back up to a pressure of 0 psi to 3 psi with nitrogen. When vacuum is drawn on the system, the moisture evaporates into water vapor. When a small amount of nitrogen is charged into the system, some of the moisture remaining in the system is absorbed by the nitrogen. Nitrogen is considered a dry gas. Before performing triple evacuation, recover the refrigerant from the refrigeration system. Also, before evacuating the system, conduct a pressure test. Before recovering refrigerant in the system, preparing to perform a triple evacuation, it's a good practice to use a gauge manifold with more than 3 ports and has 2 valves. Gauge manifolds with additional ports and valves allow technicians to perform multiple procedures with several different instruments and machines without having to break connections. So again, when you set up for triple evacuation, you want 2 additional valves on your gauges so that you could select vacuum or charge cylinder. Okay, this is a good idea anyways, regardless of using triple evacuation. It just allows you more options.